Hello, and today we're going to be looking at an area of a segment. So what an area of a segment is it's this orange highlighted area of a circle. So you have an arc, you draw a line from each end of the arc, and the area that it encloses, and that's a segment. So if we want to work out the area of this segment, what can we do? Well, we already learned in the previous video how to work out this sector of a circle, so maybe we can apply that logic to work out that and then subtract this new triangle that we've made here. So let's do just that. So first we have to decide what unit are we going to be using. So I'm going to use radians, and you'll see why in just a moment. So area equals, what did we say? Half theta in radians, radius squared, and we're going to subtract the area of this triangle here. Now we're going to subtract this area of a triangle here. So the way that we're going to do that is we need to come up with some sort of equation to work out the area of the triangle using what we have. Well, we have an angle and we have two sides, so we can use a different equation that we learned in a different video. Half base times c times sine a. So if we're going to apply this here into this equation to work out what the area of a segment is, we're going to have to work out what these things are. Well, sine A has to refer to this angle here, theta, and base, we can make one of these radii the base, and then we can say that the other side that we have to deal with is the other radius, so we can say half radius squared times the sine of theta. Now we can come up with our equation for this segment. So the area of the segment is this equation up here, but we can factor out a half r squared. So a half r squared, lots of theta in radians minus sine theta. Now, please note that I have not put any units for sine theta. The reason being is depending on what mode your calculator is in degrees mode or in radians mode, depends on what you will put here. So this could be degrees, and then you would have to convert to work out what this bit is here, or you could just put it all in radians and not have to worry about it. So assuming that we do want to use degrees, we can write the same equation, but now we have to get theta, we have to times it by pi over 180. And then we have to subtract the sine of theta again. So again, these two equations are the same, but you can see that using radians is just a whole lot easier in this case here. So again, we're going to do an example. So let's let the radius equal 2, and we'll make the angle theta equal to pi over 2. That's, and we'll make the angle theta into 90 degrees. So the area of the segment is going to equal half the radius squared of theta in radians minus sine theta. So assuming that this is all in degrees mode, I'm gonna have to convert all this. A half 2 squared is 4. We'll leave that there for now. And then we're gonna have to convert 90 degrees into 90 times pi over 180. And we can cancel that down further, but subtract sine 90 degrees. Sine 90 degrees is just 1. And 90 over 180 is just going to give me half. So half of pi. This is now pi over 2 minus 1. Lots of half of 4, 2. And we get that is equal to pi minus 2. And that there is our area. So the area of the segment is pi minus 2. If you have any questions, feel free to ask me in the comment section below or contact me on social media, and I will see you in the next video.